Then this is a system clock. Now, in one of our discussion, I told you that whatever the clock input that is applied, it is a CLK2 pin, right? The name that was given is CLK2. Now, this clock will be having, right? No, okay, this is this there. You can here you can highlight the internal microprocessor clock, right? The second waveform. This is internal microprocessor clock. This microprocessor clock, internal microprocessor clock, will be the half of the input frequency that we applied on CLK. So as per the model, right, as per the specification, it is expected to apply CLK2, right, twice the processor frequency. And then this particular processor clock period is internally, basically it is this frequency is divided in half, and then ultimately you can see processor clock is having this particular period. So this is one period of processor clock, and your CLK2 will be, as it is divided in two, so ultimately two periods F1 and F2, these two phases will be there in one processor clock, right? So processor clock period is this much, right? This is one clock period, and in this F1 and F2 are the two phases of CLK2, right? F1 and F2. Now these phases are basically used during control signal communication, right? So when we talk about the bus cycles, I will elaborate about in which phase what is happening. So when we talk about the bus cycles, in that case we will highlight about the phases, right? Phase 1 and phase 2. So here this processor clock, microprocessor clock, is internally generated by the processor, but it is mandatory to apply proper CLK2 input to the whatever the external clock frequency. So we have the three versions of 80386, 20 megahertz, 25 megahertz, and 33 megahertz. Getting this? So ultimately, when we talk about this CPU frequency, this is your processor frequency, and then the associated CLK2 will be double of it. So if your processor is 20 megahertz 80386, in that case CLK2 will be 40 megahertz. This we need to remember, right? So whatever the external clock frequency, that will be double of the processor clock, right? Now here this is a system clock that we are connecting. This understanding is important because here we will be using this phase 1 and phase 2 in our further discussion, right? Now system clock, whatever we discussed, that is given here. So I will just repeat it. CLK2, it provides the fundamental timing of your processor divided by 2 internally to generate the internal processor clock, right? And which is used for instruction execution. Internal clock comprises of two phases, phase 1 and phase 2 of your CLK2, right? So as we have shown it in the diagram, so each CLK2 period is a phase of internal clock, right? So each CLK2 period, so phase 1 and phase 2 is the phase of internal clock. All 386 inputs are sampled. Now here this is a very interesting one. Whenever inputs are to be sampled, right, it will be sampled at CLK2 rising edge. So whenever there is a rising edge of CLK2, at that point input will be sampled, right? So there are several input pins we have seen, and to check whether that input is having valid signal or not, right, it is going to sample at the rising edge of CLK2, right? Then many 80386 signals are sampled every other CLK2 rising edge. So every other CLK2 rising edge means for every CLK2 rising edge, there are some signals which will be sampled. Some are sampled on CLK2 edge when CLK is high, right? So the CLK2 rising edge of your CLK2 input clock when CLK is high, right? Now here you can see what is the CLK. CLK is your processor clock, right? And processor clock, it will be having two periods of your CLK2, right? So then few signals will be sampled during the rising age of your CLK2, and other condition is at the time CLK should be high. And there are few signals which are sampled when CLK is low. So these three groups are there. There are few signals which are sampled for every rising age. There are few signals which are sampled at rising age when CLK is high, and a few signals are sampled at rising age when CLK is low. Right. So these are the three categories of input signals. Then this table you mark it very important. You mark it very important. Now what this table is? Now this is a foundation to your next topic discussion of associated to bus cycles. Right. Now what this table is? This is a bus cycle definition signal. Right. Bus cycle definition signal. Now what it indicates? This is basically going to be decide what bus cycle your processor is going to initiate. Bro, as we have discussed about a few examples in the morning, right? Memory read and memory write operation. So here we have seen that there are two type of operations, right? The bus cycles which will be initiated. One will be the data bus cycle, and other one will be the control bus cycle, right? And it is distinguished based on the operation that is carried out. So there is a separate pin D oblique C bar that determines whether it is a data cycle or it is a control cycle, right? In that discussion again, I highlighted that when we are talking about the memory and IO read write operation, in that case those are treated as a data operations, and others are treated as a control bus cycles, right? So what type of control bus cycles are there? So those are basically interrupt acknowledgement, then fetch operation is there, and then halt or shutdown is there. Getting this? So these three are basically the control bus cycles. And in one of the discussion, let me go back to that particular signal. It is DC bar. So this was the point where we discussed about this. So distinguishes data cycles. Data cycles means either memory or IO from control cycles, which are interrupt acknowledge, halt, and instruction fetch. Halt or shutdown, right? So this is halt or shutdown, and then instruction fetch. So there are three control cycles and four data cycles, right? And one does not occur, right? So this is the does not occur condition, right? Now here you can see the pins which are basically involved or defines the bus cycle are M oblique IO bar, D oblique C bar, W oblique R bar. Right, these are the three major pins contributing in defining the bus cycle. Right now, when M oblique IO bar is low, right, D oblique C bar is low and W oblique R bar is low, right? That cycle is basically interrupt acknowledge. Now what this interrupt acknowledge is? Basically interrupt acknowledgement is associated to acknowledging the interrupt received from the external devices. So this acknowledgement cycle will be carried out by your processor to give response to the external interrupt. And this interrupt acknowledgement cycle is log bar. Right, so log means it is what the fourth signal that we highlighted. It was a log bar signal. So interrupt acknowledgement is all interrupt acknowledgement cycles will be logged. So this indicates that during interrupt acknowledgement cycle, other bus master cannot interrupt this particular bus cycle. So unless and until it won't complete the interrupt acknowledgement cycle, it will not be your other bus master will not be able to interrupt or pause this particular operation, right? So whenever interrupt acknowledgement is to be initiated by your processor, it will make M oblique IO bar low, D oblique C bar low, W oblique R bar low, right? So with all these three pins low, it indicates that processor initiated interrupt acknowledgement cycle. And with this, it also initiates, it also sends this log bar signal, right? Then low on M oblique R bar, M oblique IO bar, low on D oblique C bar, WR bar equals to high. This condition never occurs because there is no cycle defined for this particular combination. So it never occurs for your processor. Then next is whenever your processor wants to perform IO data read. Now IO data read means in instruction. When your processor is executing in instruction, that is a read operation, and in indicates that it is a IO read operation. Right. So to perform IO data read operation, IO means M oblique IO bar should be low. IO, this is IO bar, so it should be low. This is the data operation, so D oblique C bar must be high. And as this is a read operation, so W oblique R bar must be low. So whenever processor is executing in instruction, in that case, the scenario on these three pins will be low, high, and low. Right. Now, how processor decides what control signal should be generated, that in what condition, so it will be totally decided based on the instruction that is under the execution. Right. Now if your processor is executing out instruction, out is basically IO data write operation, in that case this low signal on IO bar indicating that it is a IO operation, D oblique C bar high indicates it is a data operation, data cycle, and W oblique R bar high indicates it is a write operation. So whenever your processor come across out instruction, it is going to initiate these control signals with M oblique IO bar as low, D oblique C bar as high, W oblique R bar as high. Getting this? So this particular set of control signals are basically sent by your processor control unit, right? So that external hardware will understand or can decode that particular control logic, right? So the external hardware will ensure that whatever the required units on the motherboard are there or on the system is there, those will be enabled appropriately, right? Then next one is a memory code read. Memory code read is alternately known as instruction fetch operation. Alternately known as instruction fetch operation. So during instruction fetch operation is basically the control cycle. Right? It is not a data read from memory. It is a code read from memory. Right? So it is a memory code read, instruction fetch. Right? So in this case, your memory is there. So memory M oblique IO bar is high. As this is a control cycle, so D oblique C bar will be low. And as it is a read, right, fetching operation, in that case, it is W oblique R bar will be low. Right? The next one is a halt or shutdown cycle is there. Now there are two options, right, with this particular type of cycle, right? So to perform this halt cycle or shutdown cycle, your processor will make M oblique IO bar as high, D oblique C bar as low, W oblique R bar as high, and alternately, in addition to this, it also sends address, right? So address will be 2. So this 2 address indicating that your BE2 bar, see, as per the table in the morning we discussed, when address lower 2 lines or the complete address is 2. So complete address 2 indicates what? The lower 2 bits are 10, and this 10 is associated to BE2, right? So BE2 will be low, right? So on the external side, we can understand that your processor wants to initiate the halt cycle based on this address, based on these byte enabled signals, right? So complete address is 2. So A2 through A31 will be low. So all are zeros. Then BE2 will be low, indicating that the address is 2. So with these 3 inputs, bus cycle definition signal as high, low, and high, and the address as a 2 indicate that it is a halt cycle. And if it is a processor wants to perform shutdown cycle, in that case the address generated or address sent will be 0. So when it is 0, so lower 2 bits are 0, 0, right? So in that case BE0 bar will be low. So on an external side, external hardware will understand that this is a shutdown cycle when your address is 0. So address 0 means all bits of your address lines are 0. So lower 2 bits are 0, 0. which will make BE0 bar as low and other byte enabled signals as high. Then we have memory related operations. Memory read. So memory read, so as it is a memory, so M oblique IO bar will be high. Read means it is a data read, so data, so D oblique C bar will be high. As it is a read operation, so W oblique R bar will be low. Then memory data write operation, so here memory, so M oblique IO bar will be high, data, so D oblique C bar will be high, and write means W oblique R bar will become high. So whenever we are changing the instruction, right, and based on the operand directions or the data flow direction, we can easily understand that it is a memory read or memory write cycle. And then some cycles are locked. So here we have option to lock particular data operations, right? So we can have the lock prefix for instructions by which we can lock these bus cycles, right? So here IO operations we cannot lock it, right? Then other no, control cycles, memory coded and this halt or shutdown are also not locked. For memory, we have options, right? We can select cycle by cycle. On cycle basis, we can decide if we want that this operation should be locked. Then in that case, we can set it as a locked, right? So this is how